All right. So, video number 2 for skill number 5. So this is really just volumes of cylinders, but it ties directly into cylinders in the engine, right? So car engines have a certain number of cylinders, a V4, right? Would have 4 cylinders, a V6 would have 6 cylinders, a V8 would have 8 cylinders, and so on and so forth. And each cylinder is literally a cylinder. Who knew? So that is, right, a sort of a prism, a 3-dimensional shape, and the base is a circle. So if this is kind of a sketch, just sort of a quick sketch of what a typical cylinder might look like, what we can do and what happens and sort of how this all connects together is the volume of this cylinder, right? So literally the volume of the shape gives us what we call the displacement of the cylinder in the automotive world. So the displacement of the cylinder, which in some sense, right, I guess is, as the cylinder sort of fills up with gasoline, or sort of the gas and air mixture, and then you, right, compress it, the piston goes up, goes down. So the amount of volume that you are displacing with the piston, right, the displacement is the size of the cylinder, is the volume. So there's just a couple language things here that I want to connect. In general, right, our sort of volume here should be the area of a circle times the height, and so that would be pi r squared times the height. But when you're talking about a cylinder in an engine, you don't usually talk about the radius and the height. The measurements that you get in an engine are what we call the bore. And the bore is the same thing as your diameter. So that means your radius, right, would be half of that, would be the bore divided by 2. So if you're thinking of volumes, you're talking about half of the diameter, which is the radius, which would be half of the bore. This is sort of a practical thing, right? You can more easily measure all the way across a cylinder than you could try to sort of pick out the center point and measure from there to the edge. This is just, would physically be trickier to do that. It's easier to just measure the whole thing. And then the height of your cylinder is what we call the stroke, right? And so this is sort of the piston as it moves up and down. That movement sort of is referred to as the stroke, I think, question mark. And so the stroke is going to be synonymous with the height. So whatever our sort of value is for the stroke, what that really means is it just is the height of your cylinder, right? So what does that mean? So in this question, they're sort of asking, right, this example, find the displacement, which is the volume of the piston, with a cylinder bore, right, which is our diameter of 3.25 inches, and a piston stroke, which is just the height of 4.5 inches. So this is really just sort of a language thing. It sort of is just a language translation. Sometimes people talk about math, and learning math is kind of like learning a new language, and that's true, right? There's all different sort of vocabulary. That's sort of true with learning anything, trying to sort of learn what the vocabulary sort of terms are. What in your English classes you might be calling sort of insider terms. This would be that. We're talking insider math terms versus insider automotive terms, pistons and bores and strokes, oh my. In any event, so our volume formula here is really just our displacement formula, and vice versa. The displacement is just the volume. So the volume should be the area of the base times the height, right? So we said the area, the base here is a circle, so the area there is pi r squared, right? Is pi r squared times the height. We need to do a quick side calculation, right? Because we're not given directly a radius value. What we're given is the bore, which is really our diameter. So just quick, right? The radius is the diameter over 2, which would be the bore, which is 3.25 inches over 2, is 1.625 inches, right? A little bit smaller, halfway smaller. But once I know that, everything else is just sort of a matter of plugging it in and going from there, right? So my volume, which again is my displacement, is pi times, right? So this is my radius, 1.625 inches squared, times 4.5, which is my height, aka my stroke, right? All those things are connected. So pi is 3.14. We can sort of see here we're going to end up at 37.3. I guess, just because why not, I'll also crunch these numbers. Not that I don't trust the book writers, but just to sort of see the numbers in action. Times 4.5, 37.3. Seems totally fair to me. This is a volume, so the units are cubed, cubic inches. Good to go. And that would be that. We've sort of said, I think I sort of said offhand in a previous video, engine size, and so that's also sort of displacement is sometimes measured in cubic centimeters. It's also sometimes measured in liters. In this case, we're not necessarily doing a unit conversion right here. We'll just stick with cubic inches and we're good to go. Notice also, or maybe actually I'll save this. So what I want to do next is one from the exercises. I have circled number 8, but I actually want to skip it because it's very similar to what we just did. I want to look at number 10. So the distinction here, excuse me, is between, so what is the displacement of a single cylinder versus what is the displacement of the full engine. So cylinder displacement obviously is just a volume calculation. This sort of pi r squared times the height, which of course relates to our bore and our stroke. The engine displacement, so let's read this question. If one cylinder of a V6 engine has a cylinder bore of 4.2 inches and a stroke of 3.5 inches, what is the total displacement of the engine in cubic inches? Right, so what is the total displacement? So what that means is total displacement, right, is the displacement not just of an individual cylinder, but of all of the cylinders combined. This makes it sound like it's some sort of great breakthrough. All we need to do is just say, okay, well, so what's the volume for one cylinder, right? So find our cylinder volume. And then, since this is a V6, all we're going to do is multiply by 6 cylinders, right? So this is a very sort of fast, just sort of add on to what was our initial problem, right? Find the sort of starting volume, the volume for these cylinders, and then our total displacement, our engine displacement, is just going to be whatever that individual cylinder displacement is times the number of cylinders in your engine. So you do that and you're good to go. All right, so what do we have? Bore is my diameter. So I need the radius, which is my diameter over 2. So that's going to be 4.2 inches divided by 2. That's straightforward enough. That would be 2.1 inches. So my radius is 2.1 inches. Height is good to go, right? Height is my stroke, which is 3.5 inches. Volume for my cylinder, pi times r squared times the height. So that for us, we're using our 3.14, of course, times my radius, which I just found, 2.1 inches. We can kind of keep the units in here or leave them out. It just depends. As long as you have them in your final answer, you're good to go. Times the height, 3.5 inches, right? Inches times inches times inches, inches cubed. Let's multiply all these numbers out, see what we get. 3.14 0.14, so times 2.1 times 2.1. So that's right, my 2.1 squared times 3.14 times 3.5. So 48.4659. Let's call that 48.5, I guess. So cubic inches. So that was the volume of an individual cylinder. So my total displacement, right, is that volume times 6 cylinders. Okay. So 48.5 cubic inches per cylinder times 6. Where are we going to end up? 48.5 times 6, 291. Still cubic inches, right? Because each cylinder is going to be sort of a cubic volume, so we get that value. Times 6, there's no units on the 6, is just 6 cylinders, and I guess this was sort of inches cubed per cylinder. So if you wanted to get really down into the nitty gritty of the units, you could be sort of throwing some cylinders in there, but I don't think that's totally necessary. I think it's pretty clear even without that. So that's a connection between cylinder volume and displacement, right? This is sort of a connection between some math, geometry sort of terminology and what would be sort of automotive terminology. We'll do one more video to sort of wrap up skill 5, and that'll be that. So see you over there.